Hi, welcome to another of Mythology's video. This video is on converting recurring decimals into fraction. A recurring decimal or decimals with digits that are forever repeating, that has a pattern to it. Recurring decimals have a dot above digits to indicate which ones are repeating. For instance, if we have 0.23 with dots above both 2 and 3, this would be the repeating pattern forever. 0.232323 and so on. Now for this example, it's a little different. Not all the digits have dots above them. What we would do first is write down all the 3 digits, 5, 8, 4, and then we would continue writing the repeated digit, which is 5. So it would look like this. Now, the last type of recurring decimals is when you have 2 dots in a range of digits. For this one is in between the repeating digits of 7 and 9. It means that the 1 is also repeating in the range. So the repeating pattern would be 0.719, 719, and so on. Now, moving on to converting recurring decimals into fraction. This is required of you on the IGCSE EDEXCEL specification. So here we have an example to convert 0.79 recurring decimal into a fraction. We would firstly use x to represent this recurring decimal, then writing it as an equation like this. I suggest writing in its full form without the dot above because it makes it easier to recognize the pattern, like this. We want to find 2 recurring decimals that have exactly the same repeating digits after the decimal point, so that when we subtract it, we can obtain a whole number. We do that by shifting digits. Because the number of repeating digits is 2, 7, and 9, we need to shift the digits 2 places to the left. We would do this by multiplying 100 on both sides of the equation. We then obtain 100x equals 79.7979 and so on forever. As you can see, these 2 equations have exactly the same repeating digits after the decimal point, which is 797979. Because x already has all repeating digits after its decimal point, we can assign that to be equation number 1. After getting both the equations, what we then do is subtract both equations together, with the smaller into the larger recurring decimal. As you can see, when subtracting the decimal, all the repeated digits after the point cancels out. That is why we had to form 2 decimals with exactly the same repeating number of digits after its decimal point. After subtracting, we then get 99x equals 79. Lastly, we solve x, and we get 79 over 99. If you put this fraction in your calculator, you would find that it happens to have the same value as the recurring decimal in the question. Here we have a little more difficult one, 0.643 with the 6 being repeated because it has a dot above it. We would start by again using x to represent it and writing it in its full form like this. Because the x doesn't have all its digits after the decimal point repeating, because 4, 3 aren't repeating, we need to form 2 other equations. Starting off by shifting 3 digits, as you can see, all the digits after these 3 are all repeating. To do that shift, we multiply 1,000 on both sides of the equation, getting 643.666 and so on. And then for the second equation, we can shift 4 digits to the left by multiplying 10 to the power of 4, or 10,000, to both sides of the equation. We then form the second equation. As you can see, the decimals in both equations have the exact same repeating digits after the decimal point. After that, we subtract them together. Remember the smaller into the larger. To help you understand this procedure further, when we subtract the 2 newly formed recurring decimals together, here we see that everything after the decimal point completely cancels out, leaving us with the only whole number. Then, After subtracting, we get 9,000x equals 5,793. So when we solve x, we get 5,793 divided by 9,000. That gives us the answer of the fraction. There is a methodology practice worksheet, which will be in the link in the description box down below, of solutions to help you guys consolidate your knowledge on this topic as well.
Thank you so much for watching, guys, and make sure to give this video a thumbs up and subscribe to our channel for more upcoming math contents.